Hello and good afternoon, my dear kids. Welcome back once again to this short tutorial video for class 8 students. Since we are dealing with the chapter triangles, that is under your geometry, this video will be slightly different, okay? Because since we are dealing with all the calculation part, isn't it? Most of the calculative part. So in this one, it won't be there. It's actually not much of a calculative part, okay, this topic especially. Okay, so the topic is actually congruence of triangles. Now see, what is congruence of triangles? This is very important, okay, because this one, the same will be continued in class 9 and 10 as well, okay. So this is a very important topic. So, and there's not much sum in the topic for you in this level, your level, because the sum will extend in 9 and 10, as I've already said. Simple few basics are there and a few basic sums are there, okay. We'll deal with that, okay. So what you need to understand from here is the basic of the term, that is congruence. What is congruence of a triangle means? Actually, see, congruence of a triangle actually means, and what I want you to do is please write down all the notes from this video as well, okay. And what do you actually congruence means is when, say, when two figures, it's a simple given is two figures having exactly the same shape and size are said to be congruent. Two figures having exactly the same shape and size are said to be congruent. Now actually, say, we are dealing with congruence of triangles. That means actually the shape is a triangle, isn't it? Now what you can simply say is two triangles with same size and angles are said to be congruent. Now for two triangles to be congruent, see, there are a few criteria which we will deal with later on, okay. Now so actually congruent is also known as, these congruent figures are also known as superimposable figures. Now what does the term superimposable means? Now see, now let's listen very carefully. What does the term superimposable means? See, if you have two triangles, okay, if you have two triangles like for this triangle and this triangle, if you have two triangles of same shape, same size and same angle and all, okay, and what you did was you superimpose, that is, you kept one above another, okay. So what did I just say? If you have two triangles with same shape, same size and same angles, and when you superimpose, that is, keep one above another, that is actually what happened here is, here we have placed first this angle here and second angle here. Now actually how many triangle do we see here? First this triangle and this triangle. We have two triangles with same shape, same size, same angles. So first this triangle I have kept it here at the bottom. Second triangle I have kept it over it, okay, on top of it. So place it like this. So how many triangles actually you see here? Actually you see one triangle, isn't it? Now this kind of figures are known as superimposable figures, okay, superimposable figures. That means actually congruent, what happens is everything has to be equal. The size, not just the size, the angles, the sides, the length of the sides and all, okay, those are known as congruent figures. And since we will be dealing with the congruency of triangles, so the figure is triangle, okay, we'll be dealing with triangles and it's about its congruency. Now the first one, that is conditions for congruency of triangles. So what are the conditions that makes two triangle congruent? That is superimposable figures. That means when you place one over another, you get to see just one, okay. So congruency, conditions for congruency of triangles, as I've already said, please write down the notes as well in your copies, okay. So the first one we have here is SSS congruence condition. SSS congruence condition. So SSS means actually S refers to side. So side, side and side. So the statement here, it says, see, if three sides of a triangle are respectively equal to the corresponding three sides of the other triangle. That means when three sides of a triangle is equal to three sides of the other triangle, if the lengths are same, that means see, that's why I have drawn the figure as well, see, here, with one mark here, one mark here, two marks here, two marks here, three marks here, three marks here, okay. If the three sides, that means all the three sides of this triangle is equal to this triangle, then the triangles are congruent, see, then the triangles will be, definitely they will be congruent. No need to worry about the angles. When you get three sides of a triangle equal to three sides of another triangle, those two triangles will be at that time those two triangles will be congruent. That means their angles will definitely be same as well. Okay, so that is how you need to write it. See, in for example, I have drawn figure ABC, triangle ABC and triangle PQR, and as I already told you, I have given AB is equals to PQ, BC is equals to QR, and AC is equals to PR. So that is what I have written. See, AB is equals to PQ, BC is equals to QR, and AC is equals to PR. So that time we can write simply, see, therefore triangle ABC is congruent. Now this is a symbol for congruent, like an equal to and small, like, see, like this. Okay, like this symbol, and that symbol is for congruency. So triangle ABC is congruent to triangle PQR. Now the reasoning, don't forget the reasoning, isn't it? The reasoning was important. So according to SSS, that is triple S. Okay. Okay, now the second condition we have here is SAS, congruence condition, that is A stands for angle, see, side, angle and side. Now in this one what happens, let's see. If two sides of and the included angle of a triangle are respectively equal, if two sides and the included angle of a triangle are respectively equal to the corresponding two sides and included angle of the other triangle, then the two triangles are congruent. That is in simple language. When you are comparing between two triangles, and what you figure out was two sides were equal. Okay, two of those sides were equal and one of the angles were equal. That at that time you can simply say those two triangles are congruent. Okay, for example, here I have drawn three: triangle ABC, triangle PQR. So I have given this side AB is equals to PQ, and BC side is equals to QR, and angle C equals to angle R. What was the condition? SAS, isn't it? Now see, this side is equals to this side is equals to this side. That is, two sides of this angle is equals to two sides of this triangle, and one of the angles was equal. So simply you can write it down as, see, AB is equals to PQ, BC is equals to QR, and angle C is equals to angle R. So according to SAS, that is side angle side criteria, we can write triangle ABC is congruent to triangle PQR. Okay. Okay. Now the next condition for congruency is ASA, congruence condition. Now as you can figure out what does A stands for in this, isn't it? So, but still I have written here angle side angle. Okay, ASA. Now, if two angles and one of the sides of the triangle, are respectively equal to the two angles and the corresponding sides of another triangle, then the two triangles are congruent. Now in simple words, if while comparing between two triangles, if you figure out that two angles of the triangle are equal to two angles of the compared triangle, that is, if two angles of this triangle is equal to the two angles of the other triangle and one of the sides is equal, at that time that triangle will be congruent, that is, they will be superimposable figures. When you place it one over another, you will get to see just one figure. Okay, so see here, for example, what I have given out here, here I have given ABC, see, ABC and PQR. AB is equals to PQ, angle B I have given C. I have drawn one arc. See, the symbols are very important, okay, in geometry. This will tell you about the, as I have already told you, this will tell you about the sum, about the figures as well. See, two arc, that means what? C is equals to R and Q is equals to B, isn't it? So two angles are equal. See, two angles are equal. One of the sides AB is equals to PQ. So that's what we did written here. See, AB equals to PQ, angle B is equals to angle Q, and angle C is equals to angle R. So two angles, one side. So according to ASA, we can say triangle ABC is congruent to triangle PQR. Okay. Okay, and the last criteria for congruency of triangle is this RHS congruence condition. Okay, that is known as right angle hypotenuse side. Actually, it's like similar to SAS. See, because hypotenuse and sides, these are actually sides, isn't it? Hypotenuse and sides. So SAS and right angle means an angle. But why we need to write it as RHS is because whenever you are dealing with or comparing between two right angle triangle and you figured out that those two triangles are congruent, then at that time you have to write RHS condition, that is right angle hypotenuse and side. Okay, if both the hypotenuses are equal. If not, then simply you can go with SAS. Okay. Now see the statement: if the hypotenuse and the side of a right angled triangle are equal to the hypotenuse and the corresponding sides of another right angled triangle, then the two triangles are congruent. As I've already said, here we'll be comparing two right angled triangles. So two right angled triangles I've drawn: ABC, PQR. I've given 90 degree out here, 90 degree. I've given the bases equal, BC, QR, and the hypotenuse equal, C. Now see, as I've already told you, if the hypotenuse was not equal and the perpendicular was equal, at that time you couldn't have used RHS, because this you cannot simply call it as, even though it's a right angle, you cannot call it as hypotenuse, isn't it? That time it would have simply gone to SAS, side angle side. Okay. Only when in a right angle triangle, when comparing in right angle triangle, the hypotenuse also comes equal, then you have to use RHS. Okay. So according to the figure, AC is equals to PR, hypotenuse I have given equal, BC is equals to QR, the base also I have given equal 90 degree. Okay, now simply what we can write here? Simply we can write here that AC is equals to PR, angle B equals angle Q, that's 90 degree, BC is equals to QR, and according to RHS, triangle ABC is congruent to triangle PQR. Okay, so I hope you kids understood the simple concepts regarding the congruency. So let's do a few more sums. Okay, just one or two. It will be easier for you. Okay, to see this application of the laws and all. Okay, so I have taken from exercise 17D. The figure was this. See, as I have already said, the figure tells you much about this sum, isn't it? So what do we see in the figure? See, actually we have got, see, the figure, we can figure out that ACD is a triangle, ABD also is a triangle, isn't it? And the triangle, these angles are equal. See, these angles are equal. So, but still what I have done here is, as I have already told you, while you are encountering a geometric sum with a figure, you need to first draw the figure on your answer sheet or your copy. Then you need to write the basic part, the given part, as well as what you need to supposed to do with your sum. So that is what I have written. See, given AX by 6, angle CAB and BCD. Now you might recall the term bisect. What does the term bisect means? It means it divides the angle into two equal halves, isn't it? Bisect means angle or side, but here since it says angle AX by 6, angle CAB and angle CBD, that means these two angles has been divided into two equal halves. Okay, and what we need to prove? We need to prove that triangle ABD is congruent to triangle ACD. ABD is congruent to triangle ACD. That means we are dealing with two triangles. Now see, what you can do is, in order to simplify this sum, what you can do is you can simply split the triangle. See what I have done here on the next step. ACD, I have drawn this triangle ACD, see here, separately, just to show you. Okay, or what you can do is you can do this in your answer sheet as well. Okay, just to make sure, just to be more clear about the sum. Okay, and second triangle I have drawn is ABD. See, ABD. Now see, AD, I have drawn triangle ACD. Remember this triangle ACD. So ACD. Now which one was angle A with one arc? So angle A I have drawn with one arc. D with two arcs. So D with two arcs. Okay. Another triangle was ABD. Now again, see, I have drawn ABD out here. Angle A had one arc. Angle D had two arcs. So two arcs. B at the top. So this at the top. Now what do you figure out from here? From these two triangles is angle A is equals to angle A. Okay. It was given because see, bisected angles, isn't it? Angle D was equals to angle D. Okay, well and fine, bisected angle. Now what do you figure out is AD. Now see this side AD, this side was common for both this triangles, isn't it? Or simply by looking at the name as well. See the name of the triangle ADC, ADB. See, this is the name of the triangle also, AD. The side, one of the sides is equal. So that is what I have marked here. See, AD and AD. Now how to write? Okay, we need to prove these two triangles are congruent, isn't it? Now how to write it? Now once you have splitted this and you have looked at the conditions. Okay, now we know that these two triangles are congruent. Okay, why? Because two of the angles are equal and one of the sides. So whatever will be the condition will be ASA, isn't it? Now we know that these two triangles. Now how to write? The way of writing is also very important, as I have been telling you. Okay, now see, in triangle ABD, that's what we need to prove. See, ABD and triangle ACD. So that's what I have used. Simple ABD and ACD. ABD this triangle, ACD this triangle. Now say simple. Angle A is equals to angle A. Angle A equals to angle A. Angle D is equals to angle D. Angle D equals to angle D. Bisected angles you can write. So bisected angles. Now AD this side. AD is equals to AD. What was the reason? Common side. As I have been telling you repeatedly, before writing anything in geometry, that is whether it be about angle or besides, the reasoning is very important. This is where you will get your marks. Okay, if you don't write this one, if everything is correct, some percent of your marks will be deducted. Okay, so this AD is common side, and this angle A, angle A, angle D, angle D, bisected angle. So we know two angles, one side. So which will follow? Which rule will be applicable? ASA, angle side, isn't it? So according to ASA, that is angle side angle, triangle ABD is congruent to. See, look at the symbol as well. Equal to with this sign. Congruent to triangle ACD. Okay. Okay. So we'll do one more sum for today. Okay. Just one more. Okay. And this one, question number 2. What's given in question number 2 is the figure is given. Okay. Somewhere 90 degrees also there, isn't it? We can figure out 90 degree, but big triangle is there, and lots of smaller triangles are also there. Okay, let's see which we need to use and what we need to do. Okay, with the sum. So okay, after drawing the figure, as I've already told you, the given terms. So the given term is ABC is a triangle with BD and C perpendicular. Okay, obviously it was 90 degree, means it's perpendicular. The line which draws 90 degrees is perpendicular. We know that from the right angle triangle, isn't it? Perpendicular to AC and AB, AC and AB, okay, okay, perpendicular 90 degree, and this symbol, yeah, like inverted T, it's a symbol for perpendicular. Okay, inverted T, it's a symbol for perpendicular. ABC is a triangle with BC and CE perpendicular to AC and AB. Also BD is equals to CE. Now this is BD is given as EC. That is why I marked here. See, BD is equals to EC. Now that means I guess we have to use these two triangles. Okay, BD equals AC. So we need to prove triangle BCD and CBE are congruent. Triangle BCD means this triangle. BCD and CBE this triangle, two right angle triangles. Okay, now so that is why I have taken out two right angle triangles. See, triangles with BCD. So BCD I have taken. See, BCD, this triangle I have taken, and I have, since it was a right angle triangle, so as per my convenience, isn't it, because we are familiar with this position, so I have drawn right angle triangles. See, triangle CBE was also right angle triangle CBE, so also I have drawn right angle triangle in this position. Now the 90 degree are here. Now very important part, where to place the exact names of points as well. Okay, so now see, for the first triangle, that is triangle BCD, the 90 degree is at D, the 90 degree D. And what did I taught you? The opposite side of 90 is your hypotenuse, the longest side, isn't it? The opposite is BC. So simple BC. Say I have given BC or CB. If I could have written B out here and C out here, it would have meant the same thing. BC. Okay. But why I haven't done that B here and C here is because, see, while naming a geometric figure as well, there is a certain rule for that. You have to name according to anti-clockwise. Okay, anti-clockwise. Not C. B, if you have written B out here and C out, B, C, D, the naming, look at the naming. B, after the B comes C, then D. The direction, look at the direction, this clockwise direction, isn't it? B, C, D. So what did I just say? When naming a geometrical figure too, the rule is that, this actual rule is that you have to name it anti-clockwise. So that is why B, C, D, anti-clockwise, the opposite of clockwise direction. Okay. Now another triangle, that is triangle CBE. Okay. CBE, this is triangle 90 degrees at E, so I have drawn it E. Opposite is BC, again the same hypotenuse, opposite is BC. BC, so BCE, okay, so BCE, okay. Okay, BCE. Okay. Then, but here, see, since it's not the D term was not here, so I can use BCE out here. Okay, or you can simply write B out here and C out here. It's same thing for this one because they are not in sequence, in order, isn't it? The point is coming is BC and E, not D. Okay. Now, so after that, what do you know is this, that is angle E is 90 degree, so I have drawn 90, angle D 90. Okay, BD was equals to EC, so BD, here we have BD equals to EC, so here we have EC. Now the opposite, see the hypotenuse for both the triangles, the hypotenuse was BC, isn't it? So BC, so I have marked BC, both the BCs with one arc, not arc, one mark, cut mark. Okay, now what do we know? We know that two sides on one angle is equal, so you can simply use SAS, isn't it? But since in this one it was about a right angle triangle and the hypotenuse was equal, so in order to perfect way or the correct way of writing is in triangle BCD and triangle CBE, angle D is equals to angle D. Why? Because both are 90 degree, so C equals to 90 degree, because this symbol was given. Okay, and it was also said it was perpendicular, so equals to 90 degree. CB is equals to BC, common side, or you can simply write hypotenuse, isn't it? Then after that DB equals to EC, DB equals to EC, it was given out there, so DB is equals to EC, so given out there. Now according to RHS, that is right angle hypotenuse side, we know triangle BCD is congruent to triangle CB. Okay, I hope you kids understood today's lesson. Okay, if you have any problem regarding the sum, then please do let me know. Okay, so till then, stay tuned in for more updates and more videos. Okay, and please write down all the theoretical parts in your copies as well. Write down all the sums that we have done on the video and practice the same sums as well. Okay, so till then, stay safe. Bye bye.